In this lesson, we're going to use x and y intercepts to graph a linear equation that's in general form. We've already looked at linear equations in general form, and we know how to solve them for y so that we can see the slope in the y-intercept. But sometimes if all you need is a quick graph, it may be more convenient to plot the intercepts than it is to solve for y to use the slope in y-intercept. And here's how you find each intercept. To find the y-intercept, you're going to plug in 0 for x. To find the x-intercept, you're going to plug in 0 for y. Now, why does this work? The reason that this works, if you look at this line, you can see that the y-intercept has to be on the y-axis, and at every point on the y-axis has an x-coordinate equal to 0. And the same thing for the x-coordinate. Because it is on the x-axis, we know that it will have a y-coordinate equal to 0. So whichever intercept you want to find, you plug in 0 for the opposite variable. If I want to find the y-intercept, I plug in 0 for x. If I want to find the x-intercept, I plug in 0 for y. So now let's use intercepts to graph 4x minus 6y equals 12. First, we will find the y-intercept, and when you find the y-intercept, you plug in 0 for x. So this entire term becomes 0, and that leaves us with negative 6y equals 12. Now if I divide both sides by negative 6, I get y equals negative 2, which is the y-intercept, and I can go ahead and plot that on my axis, on my y-axis, because this is the y-intercept. Now let's find the x-intercept. So to find the x-intercept, I'm going to let the y term become 0. That will give us 4x equals 12, or x equals 3. So here I've plotted my x-intercept. Now notice this is not a slope. This is not rise over run. I have here y-intercept and x-intercept, so two separate points on the line. And once you have 2 points, you just graph the line. And so this, when you graph using intercepts, you don't see rise over run at all. Let's do another one. Here is 5x plus 6y plus 30 equals 0. So if I find the y-intercept, I'm going to let the x term become 0. That'll give us 6x plus 30 equals 0, or sorry, 6y plus 30 equals 0. So 6y equals negative 30. So y equals negative 5. And here's our point on the y-axis, negative 5. And then to find the x-intercept, I'll plug in 0 for y. The y term becomes 0. And when I solve, I get x equals negative 6, which will be over here. Connect the dots. There's our line. Now this whole approach of using intercepts works best if both the x and y intercepts are integers, or what I mean by that is whole numbers, either positive or negative. By definition, whole numbers are positive, but if we say integers, it includes the positives and the negatives. So if your x and y intercepts are not going to be integers, it may be best for you to solve for y and graph using the slope in the y-intercept like we did in the last lesson. So let's try to graph 4x minus 3y plus 18 equals 0. So first we'll try to find the x-intercept. So we will let the y term equal 0. 4x plus 18 equals 0. That gives us 4x equals negative 18, or x equals negative 18 over 4, which can be simplified to negative 9 over 2. Now, if I had to graph this, I would say that negative 9 over 2 is equal to negative 4.5. But usually, what I would do before I even start this problem is I would say, oh look, my x-intercept is not going to be a whole number, so let me solve for y instead. And so to solve for y, we will take our x term and our constant to the other side of the equal mark, where they will become negative 4x minus 18. Divide everything by 3, and we're going to get positive y equals positive 4/3 plus 6 because negative 4 divided by negative 3 would be positive 4 over 3, and negative 18 divided by negative 3 would be plus 6. Okay, now I have a slope and a y-intercept. So to graph this, I will plot the slope of 6, and I will use the y-intercept of 6, and I will use my slope 4/3 as rise over run. Now it's kind of not convenient for me here to go up 4 and right 3. So instead of going up and right, what I can do, remember, is go down and left. And I'll plot a point here. And now we'll connect the dots. And this is our line. And if you'll notice, the x-intercept, 1, 2, 3, 4.5. The x-intercept is at negative 4.5. So it can be plotted using the intercepts, but it may be more convenient for you to stick with the whole numbers. That is totally up to you. Now let's graph one more together. Let's do 8x minus 2y plus 12 equals 0. So the first thing I'll do is look at the x-intercepts, which is going to be, or x-intercept singular, which is going to be 8x plus 12 equals 0. So 8x equals negative 12. That's going to give me a fraction. So let me stop right there and use the slope-intercept form instead. So that's going to give us negative 2y equals negative 8x minus 12 if we solve for y. Divide everything by negative 2. And we will get y equals 4x plus 6. So let's graph this. Our y-intercept is at 6, and our slope is positive 4, so we would go normally up 4 and right 1, but as you see, that's kind of off my graph. So instead of up 4 and right 1, I think I'll go down 4 and left 1. And now let's connect the dots. And notice that the x-intercept is negative 1.5, which is negative 3/2, which is what I would have gotten here if I had continued. Negative 12 over 8 would simplify to negative 3 over 2. So it all fits together, but it's just a matter of choosing the method that's most convenient for you.